If you are using ODP.NET or JDBC, you may not be aware, but by default, auto commit is turned on in these packages. This means that every time you issue an insert, update, or delete command, if you have not taken care to wrap this block of data access code in a transaction, this command will automatically commit to Oracle. This is different than in tools like SQL Plus or SQL Developer, where, as you probably know, you have to explicitly issue a commit command in order to commit your changes to the database. Having auto commit turned on by default has some big implications. First of all, you may really want your data to be inside of a transaction, meaning all of your changes commit or none of them do so. So if this is the behavior you want, you need to explicitly create a transaction in your data access code and manage it so you get this behavior. Secondly, though, from a performance standpoint, if you are committing too often, this could actually slow down your data access code that uses DML. Let's see what we mean by this. We're taking a look at a piece of data access code in C#, and what this code is going to do is take all of the course offering IDs a student has registered for in a term and insert them into the course enrollments table. Since most students take anywhere from 4 to 6 courses in a semester, we would expect this work to commit as a logical unit of work. That is, either we insert all of the courses that the student is enrolling in or none of them. In this piece of code here, we're just using the default behavior of the ODP.NET driver. And this is the same default behavior that you have in the JDBC driver. So as we loop through these courses and run our command right here, since auto commit is on by default, what is happening is an implicit commit is being issued with each statement. Now you might say, what is the big deal about that? If we picture what's really happening though, we're executing a statement and then committing, executing a statement and then committing, and so on. Remember, Oracle is an ACID-compliant database that ensures the consistency of its data at all times. That is one of the reasons why you use Oracle, is because Oracle will guarantee that a transaction will not get lost. So up on the Oracle server, whenever a commit occurs, Oracle must make sure that the data is written to its transactional redo logs before it can return from the call and tell your application that the insert succeeded. This way, if for any reason the Oracle server was to crash the instant after this happened, your data would be safe and not get lost. This is one of the distinguishing features of a relational database, the data consistency that they offer. So returning to our code, what is happening here is however many courses are getting passed in this array, that is how many times we're going to commit the data in Oracle. And this is probably the wrong answer for 2 reasons. 1, it isn't very good for performance. And 2, if our application were to crash, say after record number 2 was inserted, we wouldn't be in a very good state data-wise, because our student would be enrolled in 2 courses, but not in the other courses that they were trying to sign up for. So we can't just rerun our process to insert the data, we'd have to rerun just part of our process. And this is one of the reasons why you use transactions, is to avoid these sticky situations. Now we can solve both of these problems by using a transaction, so let's scroll down and see how we do that. By wrapping our data access code in a transaction, we're going to get the business behavior that we want. And now, since we're only going to issue 1 commit, Oracle's going to have just 1 disk operation to write to its redo logs rather than 5 or 6 like it would have had before. And so this saves time on our Oracle server. Let's imagine for a moment that rather than inserting 5 or 6 rows, we were inserting 1,000 rows. And then it's very easy for us to imagine that doing just this 1 disk operation would be faster than doing 1,000 separate disk operations, even if that 1 disk operation that we were doing was a little bit larger than any of those individual operations. Whenever you get a lot of small chatty operation, that tends to be very slow. And in this case, when we have auto commit turned on, what it's like is that we're paying a small tax on each DML operation. Now you should not change how often you commit based solely on performance. The size of your transactions should be determined by your business need. If it makes sense from a business standpoint to commit after every row, then that's what you should do. An example of this might be inserting data into an error logging table. In this case, you do want to insert after every row because you don't want to wait for another error to occur because you might lose data and that data might be important to resolve the problem. But if you do have some DML statements that should be part of a larger transaction, it's important to know that you can and probably should explicitly spell out your transactions in your application code and not rely upon the auto-commit behavior because this probably isn't what you want. Explicitly spelling out your transactions will give you the business functionality that you're after and also help you in terms of performance. I've seen a number of programs over the years whose job it was just to import data into a database. And many of these programs didn't define their own transactions, so they were auto-committing after each row. Just by changing the program over to properly use transactions provided a significant performance increase. So be aware of how the ODP.NET and JDBC drivers are configured by default. And make sure for your transactional data you have the right transaction scope, as you can get both a functional and performance benefit.